So in question 8, we're given 2 points, and we're asked to, first of all, come up with the equation of the line that travels through those 2 points. Also, we're asked to give the length of the line segment that connects those 2 points, so the length of line segment AB. And then finally, we're asked to identify the location of the midpoint, the point in between those two, equidistant from each point. So let's start with the first part, right? What's the equation line that goes through those? We've been down this road before, right? In order to calculate or find the equation line, we do definitely need the slope. And slope is change in y values divided by the change in the x values. So I've highlighted the y's in yellow, and I'm going to figure out the change in the y's. And then we're going to divide that by the change in the x's, and I've highlighted that in green. So it's this ratio of delta y divided by delta x. So for the change in y, I'm going to write 8 minus 3, and I'll follow that same pattern. I'm taking, this value, and then I'm subtracting this value from it. So I'll start at the 1 check mark and then over there. So 8 minus 3. And then my denominator for my change in x, that's going to look like 6 minus a negative 4. So my numerator is the number 5, and my denominator is the number 10, right? 6 minus negative 4 is 10. So that means that my slope is the number 1/2. So that's the slope of the line. What I need to do now is figure out what the y-intercept of that line is. So what we've been doing is, starting with a general equation of a slope in y-intercept form and picking one of our 2 points. I guess I'll pick this point, the 6, 8, the second point. It has an x value and it has a y value. So what I'm going to do is I'm going to plug the y value from that point in. So I've got an 8, and that equals my slope, which is 1/2, times my x value, which is 6, and then I will add b to that. So again, I've just plugged in the y from the point, so the 8. I plugged in the slope, 1/2, and I've plugged in the x value, which is this value 6 right here. And you'll notice the only variable I have left is the b, and I need to solve for b. That is my y-intercept. So this equation becomes 8 is equal to 3 plus b, and if I take away 3 from each side, 5 is the value of b. So b is 5. Those 2 pieces of information together are enough to write the equation of a line. If you go back up and you look, right, the things that we need are, we need to know the slope, and we know that value of m, and we also need to know the y-intercept, and we know both of those. So we can now write the equation of the line. It is simply y equals 1/2 times x plus the number 5. So there's the equation of the line. The next thing we need to know is how far apart a and b are. And I'm not going to do a super accurate graph. I just want a little sketch here. One of my points I'm going to plot here, -4, 3. That's the coordinates of one of the points. The other point is over quite a bit. It goes all the way to x is 6 and y is +8. So I'll just sketch this here, 6, 8. So if I look at it, there's definitely a change in y, and there's a change in x. And if I look at those values, it forms a perfect right triangle, right? Because the change in the y values are perpendicular to the change in x values. So I end up getting this right triangle. And what we need to figure out is the length of this line segment, right? This hypotenuse, if you will, of a right triangle. And that's exactly what it is, right? It's the hypotenuse of a right triangle. And if I could figure that out, I've got the distance between these 2 points, the 2 points A and B. So if I look, we were just looking at this recently on the previous problem, right? How much does y change? Well, y goes from 3 up to 8. So when I travel from 3 to 8, that's a change of 5 units. So my change in y is 5 units, which is what I saw over here, right? And if I look at my x values, my x's go from -4 all the way to a +6. Well, if I travel from -4 to +6, that's a change in distance of 10 units. So I know on this right triangle I have a leg that's 5 and a leg that's 10, so I can calculate the distance. The distance squared is 5 squared plus 10 squared, which is 25 plus 100, which is 125. So that's the distance squared. That means that the distance would be the square root of that number, the square root of 125. And when I calculate that using my scientific calculator, I get the distance is about 11.2 units. So the distance between A and B is about 11.2 units. So that's the length of line segment AB. And then finally, we need to figure out the midpoint of segment AB. So let me zoom out so we can see the points and write the mid segments, or the midpoint. So a midpoint, right, is just a point, right? It's got an X and it's got a Y. And if I want to know the X value at the midpoint, it's simply the average of my the X's. So if you can see, I wrote them in green right there, right? So my two X values, I had a -4 plus a 6, and I'm going to add those and then divide by 2. -4 plus 6 is 2 over 2, gives me that my X value at my midpoint is 1. And then the Y value at my midpoint is, I've got a 3 plus an 8. And those I highlighted in yellow, so I'll highlight those in yellow. When I add those and then divide by 2, that gives me 11 halves. So I could write that as 5.5. So my midpoint is the point X is 1, Y is 5.5. So there we go. We've got the equation of the line. It's Y equals 1/2 X plus 5. The distance between points A and B is 11.2 units. And the location of the midpoint is at the point 1, 5.5. In question number 9, it says, are the triangles below congruent? If so, state the triangle congruence condition that justifies it and complete the congruent statement. So these are starting to feel kind of familiar, right? If I look at these, I do have an angle, and then I've got this side. So I would say, yeah, these are congruent by angle, side. And then I need to get the right order here. It's triangle A, and then B, and then C. So I would say that that would go with triangle A, and then D, and then C. So triangle A, D, C. And those are congruent by angle, side. In part B over here, I've got a lot of angles, and I can even get more angles, but it turns out angles are not enough, right? I need to have the length of one of these sides, and there's no information about sides here, and they don't share any sides in common. They just share this single point. So we would have to say there's not enough information here. So I guess I would say these are not necessarily congruent. They could be congruent if I had some more information about the sides, but based on what I've been given, I can't say that they are congruent. And then the last question, on this page, it says solve the system of equations below and include a check for your solutions. When I look at this, there's a lot of different ways I could solve this. I could do substitution. I could get y alone in the first equation and then plug that into the second equation. I could also do elimination. I think I'm going to reorder this just once. I'm going to rewrite this as, let me do this. Let me rewrite this as 2y plus 4x equals 6. So I've got the y and then the x and then the 6. And you can see this matches up above. I've got y minus 3x equals -2. If I multiply this first equation through by a -2, my y's will eliminate. So I'll use the method of elimination, not substitution. So this is going to become -2y plus 6x equals a +4. So as we eliminate, right, you can see this -2y and 2y equals 0. So I have equal things, and I'm adding equal things. I will get equal things. This becomes 10x equals 10, therefore x must be the number 1. And if I plug this value into either one of the equations, I guess I'll pick this second one. It says 4 times that 1 plus 2y equals 6. That means that 2y would have to equal 6 minus 4, or 2, and y is 1. So that's not a very interesting solution point, but it looks like the solution is x is y and x is 1 and y is 1. So 1, 1 is a solution point. Now to check that, basically both of these equations have to be true. So I'm just going to plug 1, 1 into the first equation, and I'll highlight it in green. And then I'm going to plug 1, 1 into the second equation and just see that I get the things that I'm supposed to get. So again, my solution, I believe, is that x is 1 and y is 1. So 1 minus 3 times 1 is supposed to equal negative 2. 1 minus 3, it is negative 2, right? So because I get negative 2 on both the left hand and right hand side, it definitely satisfies the first equation. So let's try the second equation. It says 4 times 1 plus 2 times 1 is supposed to equal 6. Well, 4 plus 2 is clearly equal to 6. So because I get 6 on both sides of this, it satisfies the second equation as well. So 1, 1 is definitely the point where those two lines will cross.